Hi, this is Sung, your online maths mentor, and you're going through the Extension 1 program, and we're in particular doing the topic of circle geometry. Okay, so welcome to episode 14. And in episode 14, we are going to look at what is not commonly known as the angle in the alternate segment theorem. Okay, now the angle in the alternate segment theorem goes something like this, right? It says an angle formed by a tangent to a circle with a chord drawn to the point of contact is equal to any angle in the alternate segment. So let me just explain what that means using this diagram here. So if you've got a tangent to a circle, and you've got an angle that a chord makes with the tangent at the point of contact, then that angle is equal to the other angle in the alternate, not this segment, but in the alternate segment. So in other words, this segment here, the rest of this circle, right? This angle is going to be equal to that angle. Yeah. All right. Let me just show that with a red pen, with this angle here, right? So that angle is going to be equal to x, and I put a question mark there because we are going to try and prove that they're equal, right? So are they equal? That's the question that we're going to answer today, okay? So how do we go about doing this? Basically, here's how the proof works, right? Let's set up the proof first. Let's look at all this information that we've got here, right? And I'll explain the information that we've got, all right? So we've got the chord BT, right? Which is the chord that's making the angle with the tangent, and in this case, the tangent's PW, right? At the point of contact, which is T. So that's the point of contact. That's the angle. The angle we're interested is in X, all right? And O is the center of this circle, right? Okay, so we want to try and show that angle BAT, which is BAT, that's called the angle in the alternate segment, right? We want to try and show that that angle in the alternate segment is equal to BTW, which is that angle there, okay? Not only that, but the second part of our proof, right, is that we want to show that BCT, which is this angle here, is going to be equal to that angle there, all right? But I'll go through that in the second part of our proof, right? And so the first part of our proof is to show that BTW is equal to BAT, so that this angle is equal to that angle, right? And the second part of our proof is the supplement of that, okay? BTW and BCW, which is that angle there and that angle there. But we'll go through that in a second, right? So here's the proof. First of all, we need to produce, all right, the radii OT and OB, right? And that's going to become very handy for us, because if we let BTW equal to X, which is that angle there, right? OTB, which is that angle there, is going to be 90 minus X. Now, can you see why? Because the angle that OT makes with TW is going to be 90 degrees. So this angle here is going to be 90 minus X. Does that make sense? All right. So that's going to be equal to 90 minus X. And the reason why is because you got complementary angles or adjacent angles in a right angle, okay? And then we also know that that angle there, this angle here, is also going to be 90 minus X. And it's going to be 90 minus X because this is an isosceles triangle where the equal sides are your two radii of the circle, right? And so this angle is equal to 90 minus X, that angle is equal to 90 minus X, which means this angle here, right, TOB, is going to be 180 minus 2 lots of 90 minus X. Because really what it is the angle sum of a triangle. So it's 180 minus the sum of these two angles, right? So that's how we got to this stage. So it's 180 minus 2 lots of 90 minus X. We simplify all of that down. We get that that angle here is 2X. So that angle there is 2x. What does that mean that angle there is? Well, this angle is the angle at the center made by chord BT or BT. This is the angle at the center. The angle at the circumference is going to be half the angle at the center, right? So this angle here is going to be half of 2x, which is x. Yeah? And can you see that if BAT is equal to x and BTW is equal to x, then bingo, we've just proved that theorem 14 is true. Yeah? So we've just proved this part of the proof, that BTW is equal to BAT. So this angle here is equal to that angle there. Does that make sense? Fantastic. In the second part of our proof, we're going to prove this bit here. So I'm going to pause the tape, I'm going to clear the board, and then I'm going to go through the second part of the proof. Thank you for watching for the time being. I'll see you very shortly. Hi, welcome back. So now that we've proved this bit, which is BTW is equal to BAT, in other words, this angle is equal to this angle, and I've put it in blue, right? So that the angle made by a chord to a tangent at the point of contact is equal to the angle in the alternate segment made by the same chord. Now that we've proved that's true, well, we're going to prove that it's also true for the other side. So in other words, the other side being when you've got the angle, when you're considering the angle made by the chord in the major segment. So in other words, where the angle's obtuse, right? And basically, that's the second part of the proof, and that is when BT, we're going to try and prove that BTP is equal to angle BCT. So in other words, this angle here and this angle here, okay? So let's go through it. First thing I want you to know is we're going to start with what we already know from part A. So we now know that BAT is equal to BTW, right? So that the angle in blue is equal to the angle X in blue in the other side, right? So we're going to start with that. Okay, now I also want you to note that because a tangent is a straight line, the other angle, the supplementary angle, will be 180 minus X, because exactly that, it's supplementary, it's a straight angle, right? So BTP is equal to 180 minus X. Does that make sense? Now I also want you to know that BCT is 180 minus X, right? Because it's opposite to the angle in the alternate segment, right? So in other words, this angle here, X, is supplementary to this angle here, so that means that angle's 180 minus X, right? And the reason why is because they're opposite angles in a cyclic quadrilateral. So remember that from the previous theorem. So that angle there is equal to 180 minus that angle there. That's equal to 180. Now, if this is equal to 180 and that's equal to 180, then bingo, BTP, angle BTP is equal to angle BCT. 180 minus X is the angle, right? And therefore, theorem 14b is true, okay? So what that's saying is essentially that part A doesn't matter if the angle is acute, or part B, whether the angle is obtuse. What you'll find is that the angle made by a chord to a tangent at the point of contact is going to be equal to the angle in the alternate segment. That's what it means, okay? So thank you very much for watching. What we've done is we've proved this one here and we've proved that one there. In the next episode, we'll be taking this one step further. Thank you very much again. See you soon.